Okay. Our our objective today is going to be, how do we automate this system and make it smarter than it already is? Right. So everything about Grasshopper, at least for the most part, how we're going to be using it in this class, is trying to figure out smart ways that we can create automated workflows. So in this case, what I notice, and this is the problem we ran in last time, is that I have exactly the same number of subdivisions on every single panel. Um, what I think I want to do is take, well, so the objective here is I want to create one definition that I can map onto every single surface of all of my buildings. And that kind of works. We have to, if you recall from yesterday's class, we actually had a complete solid that we decided, maybe that's not the best method. Maybe I want to extrude it without the top and bottom so that I can get it to map onto every single surface. So that's kind of the first step of difficulty that we overcame. The next one that we're going to do here is, we're going to map it onto every single surface across the entire site just to give it some, magnitude. But we're also going to change the rule set so that it will reduce the number of subdivisions for panels that are of a particular size. So that way, in this kind of panel here, we might get 2, maybe 3 maximum subdivisions in the U direction. Does that make sense? So if you think about this whole idea of we're constructing geometry, we're deconstructing geometry, and we're reconstructing it into something else, and I'm going to give you a hint here. It's under surface and analysis, and I'm not saying like which tool particularly, but the fact that we need to use analysis tools is kind of your hint. But the question I'm posing is, well, how do you think we can tell the difference between a big surface? Let me just hide this one. So how do you think we can tell the difference between a very big surface like this and a small surface like this one? Area is one option, yeah. Any other options?
X direction, X length.
Right, length, yeah. So those are two very, very obvious ways of measuring the size of a panel. And so as we move forward, we're going to need to think about, well, which one is actually going to serve us best? A difficulty that we have here is, let's say I make every panel that is less than 500 square feet is only going to be one single subdivision in the X direction. Well, what happens when I have a building that's 15 feet tall versus 55 feet tall? Right? You're going to get an imbalance between the two when it's measuring by area in this particular case. So what we're going to do is analyze the length of a side, or at least I think that's the route we're going to have to go. And then that'll be our determination for how many subdivisions that panel gets. Does that make sense to you all? Okay. But the first challenge we have is that now we have to readjust our models, our buildings, so that they will work. If you recall from yesterday, instead of, let me turn them back on real fast. Yeah, sure, that one will work. So if I had a building here and I did my extrude curve and I pulled it up 55 feet as it was solid, remember, we could not exactly predict or control which sides, which number was being assigned to which particular side. So we decided, well, rather than going by the number of sides, maybe I could actually just develop an automated system, which is this, that just takes all of the surfaces, which are these, and it packages them into data that can be processed as an individual item each time. Do you recall that? More or less. I don't expect you to have a full visual understanding of it at this point, but at least you understand what happened. So what we need to do is isolate information in our drawing so that we can remodel it in such a way that's actually going to work for us. And you'll find that you wind up doing this a lot when you're working in Rhino and Grasshopper, is reconstructing something in a different way. The good thing is once you get it reconstructed, you pretty much don't have to touch the geometry again. So I'll start with my 55-foot buildings, and I'll just extrude those to 55 feet, but make sure that solid equals no. Sorry, I need to be on the layer. Solid no, 55 feet. That's good. They should show up as poly surfaces like this. And so after that, I'm going to switch onto the 45-foot layer. Select them all. Extrude curve, 45 feet. That's great. You guys are getting a sense for how easy this gets, right? Once you understand all the commands, I'm sure. Yeah. All right. So what that did was, now instead of buildings that have caps on them, now I have buildings that are entirely built out of poly surfaces that are just walls. So essentially I could pick any single one of these and it should remap all of these surfaces onto each one of these walls. So I'll do that right now as a test, and I'm just going to do it on one at first, and then I'll redo it on the others. So I'll go here, say set one brep, put it on this one. Okay, and for all intents purposes, that one worked out. And so I can try a more complex form here. I'll do the same thing, set one brep as a test. I'll put it on there. Okay, so you can see the versatility here in this particular program. So I'm not going to put it on every single surface right now. I'm going to leave it on probably 1, 2, or 3 surfaces as we move forward. But what I think we're going to have to do is spend a moment here as a group to just take the time to, you can take your solid geometry and keep it, but you should probably, get to the point where you don't have a top and bottom on these. So you should re-extrude them just like I did so that they are not solid. Does that make sense? Take your silence as a yes. So I imagine it'll probably take 10, 15 minutes.